Okay, we're going to now explain what the heck is a radian. A radian has something to do with like degrees. It's a different type of measurement for measuring angles. Like you can measure a something in inches or in centimeters. You can weigh somebody in pounds or in kilograms. Well, an angle can be in degrees or in radians. And we know this is 90 degrees, that angle right there. And then obviously if I want to split it into 1 degree it's not that big, but I'm just eyeballing. Maybe that's 1 degree. It's probably way bigger than 1 degree, but we know that to go halfway across the circle, that's 180 degrees, and we know to go all the way around the circle, it's 360 to get all the way around the circle. But what is it when you go in radians? Well, radians have to deal with radius, basically. And instead of this arbitrary measurement of a degree, they figured, well, every circle has a radius. And so this distance right here is the radius. We're going to take that distance, and I'm just going to eyeball it. That green line, which was the radius, I'm going to eyeball it. And that's about the same. Well, that radius, if I bend it around the circumference, this is considered 1 radian. It is the length of the radius. It's basically the length of the radius here. All right. And of course, if your circle was bigger or smaller, it still would be the same opening. So this opening here to here is 1 radian. And just by the eyeball test, if I took it and put another one here, and then maybe another one here, it's kind of like, well, how many of these radians would make half a circle to go all the way across? It looks like it's around 3. I mean, I'm just totally doing the eyeball test here. But each one of these is one more radian, one more radian. And the actual distance here, I'm misspelling it, sorry, to get halfway across, it's not exactly 3. It's actually 3.14 radians. And you'll probably recognize that 3.14 represents pi. And instead of saying 3.4 radians, they're just going to say pi radians. So we know in degrees, it takes 180 degrees to get to here. If we're in the radians, to get halfway across, we would just call it pi amount of radians, which again, pi is a number. It's 3.14 radians to get halfway across the circle. If we kept on going with our circle in degrees, we know it's 360 degrees to get it all the way around. Well, if we kept on going, it's 1 radian to get halfway across. It's 2 radians to get all the way across. And again, 2 radians really means 2 times 3.14. So it's really like 6.28 radians to get all the way across. Again, radians are these openings here, the same length of the radius. So whatever this radius is in green, I could just apply it once. That's 1 radian, 2 radians, 3 radians, 4 radians, 5 radians, 6.28 to get all the way around a circle. 2 pi. By the way, if you notice why the heck 2 pi looks familiar, because circumference, which means going around the circle, is 2 pi r. 2 pi to get all the way around the circle. So that is what a radian. It is an opening. The opening of the radius with the radius, this is 1 radian. Okay, now we are going to describe how to change degrees into radians. I kind of cleaned up the picture from the last part. Again, a radian is the length of the radius. So this green line, which I'll now highlight in red, if I take that radius and wrap it on the circumference, that distance is 1 radian. If I keep that same green thing, that's 2 radians. Again, slice of the pie, this is 3 radians. Now 3 radians is obviously, radians are way bigger than degrees, because 3 degrees would be like maybe that much. Well, radians are way bigger. And if I go all the way to the halfway mark, it is not 180 degrees, it is pi, 3.14 radians, and then get all the way across 2 pi. Okay, so again, that's just repeating the first part. So now, how do I convert degrees into radians? Like, how do I, this 90-degree angle, which we see right here, how do we know how many radians that would be? If I just look over here on the top, it looks like it's somewhere in the 2 area, but this is what we'll do. there is a relationship, a ratio of 180 degrees and pi radians. So when you are given the degrees like 90, you are going to multiply that by pi radians over 180 degrees, since pi radians halfway is the same as 180 degrees halfway. When I multiply this out, the degree symbol actually cancels out, and this will actually be 90 over 180 is 1/2 pi. So to go here to here, it's 1/2 pi in radians, which sounds very strange, but that is an actual number. Okay. Okay, now I'm going to go kind of cleaned and change things around a little bit. We're going to go, how do we change a radian into a degree? So again, a radian is from the center to the edge is the radius. Take that green line, apply it on the outer rim. That opening, if that's the same distance in green, that's 1 radian. Well, 1.5 radians, that's what we're going to play around with. So I'm just going to eyeball that green line and maybe just go halfway. So maybe, how big is this opening here? If that's 1.5 radians from here to here. Well, how do we turn that into degrees? Well, again, we know the relationship between radians and degrees is 180 degrees, half a circle is like half a circle pi radians. So what we'll do is take the radian number, which we say is 1.5 radians, and we are going to multiply that by 180 degrees over pi radians. Pi is a number. Pi is 3.14. What will happen here is radians will just cancel out. We'll go to the calculator here. We'll go 1.5 times 180 degrees, and that is 270 divided by pi, and this is in degrees. So again, pi is a number, so I'm going to divide it by 3.14, and this will be about 85.98 degrees. So that opening right there is, not only is it 1.5 radians, this red angle, it's also 85.9, basically 86 degrees. So you're going to use this equation right here to turn radians into degrees, or this one right here, which is just the reciprocal, to turn degrees into radians.